So calculating and interpreting Pearson's product moment correlation coefficient by hand. So when we talk about Pearson's, that's R, right? This value that we're calculating is R, and that's the correlation coefficient. So it tells us something about correlation, the strength, and the direction of that relationship. So back to our guessing the age activity, what we want to be able to do is figure out, okay, what number can we put to our own data set that would help me know how well did I do? And that's where R, Pearson's correlation coefficient, comes in. So this formula, this is something that you don't have to have memorized. It's something we're going to do by hand here, but it's not something you have to replicate on an exam by any means. You would always use your calculator to do this. So measuring correlation. We've talked a little bit about what is correlation, about interpreting correlation, but let's actually do some calculating of that value ourselves here. So correlation, again, gives us the strength of a linear relationship between two variables and the direction. Right? So notice in this calculation, we have a couple things. X mean and Y mean are simply the means of the X and Y data, respectively. And then we've talked about this symbol as well a little bit. That just means the sum of all of those calculations. And that's where you'll see a table that will help us set these up to help us calculate R. The value of R can take on values from -1 to +1, nothing outside of that range. So we have, if it's positive, right, so the sign of that number indicates whether it's positive or negative. So the sign indicates the direction, and the size of that R indicates the strength. So if R is close to +1 or -1, that means it's really strong. If the value is close to 0, that indicates a weak correlation, right? So strong versus weak. Okay. You'll see the following table on your paper, and it has just a guideline, right? So this is not an exact. There's nothing saying that you have to say, okay, if it's 0.87, then it's a strong positive correlation. This is just a guideline, but you need to be able to be comfortable with identifying whether it's strong versus moderate versus weak. So from, I'd say about 0.8 and above, strong, moderate, again, there's no exact value that you would say it's moderate, but if you're around 0.5 to 0.87, that just gives you a guideline. And then weak, anything that's close to 0 would be referenced as weak. The sign just tells you the direction, okay? Whether it's a positive or negative trend. Okay? So we're going to use that table a little bit, but first, pop quiz. True or false? You can use a graphing calculator on any IB exam, test, or quiz. That is true, right? You are never without your calculator. So you may be asking yourself, why are we going to do this by hand? This comes back to this whole unit is a lot of what you're going to do for your project, your IA. So when we do this by hand, this is showing you the process that you would have to use to show your work for your project. Okay? That's the important part here. So anytime else when you're asked to calculate R, it would be with technology only. So we're going to jump into example 3, and notice we're going to use a data set that only uses 4 data values that we're going to use together. And it is the volume of water and the time it takes to boil. So we're going to see if there's any correlation between those two things. If you had to guess for yourself, I bet you from experience boiling water, you probably know what the relationship is. Well, let's see if we can put a number to that. So from this data set, here we go. We have our X and Y list. That's just the list from both data sets. So there's the X and Y list. And then if you notice, we need to calculate the mean of both of those things. So the mean of the X data, which is the volume, the mean of the X data would be the sum of those values divided by 4, which is 12 divided by 4 is 3. And then for the Y values, the time to boil, so 24 divided by 4 is 6. Okay? So we have the X mean, we have the Y mean. And now the rest of this table is just doing parts of this calculation one part at a time. So the X minus X mean column. you're just taking all of your x values minus the x mean. The y minus y mean, all of your y values minus the y mean. That next column, notice you're taking, the only thing you really have to calculate is the multiplying those two previous columns. So -2 times -3. That's where the 6 came from. -2 times -3. We already calculated that here and here. Right? So each of those calculations comes from the previous two columns being multiplied together. And then that next column comes from taking the x minus x mean column and just squaring it. And then same for the y minus y mean column, taking that column and squaring it. So you've already done most of that work, you just have to do the squared piece. Now be careful, when you square a negative number, it's positive, so that's where you gotta make sure you're using parentheses. So here is the kind of last few steps here. We need to do some sums, we need to add up some of these columns, and those columns that we need to add up, you'll notice in the little formula here, there's 3 values, 3 sums that we need. We need to find the sum, right? So the sum of this column, and this column. So then we're going to take those sums and plug them into our formula. So the numerator, right? The numerator comes from let's see if I can color code this a little bit here. The numerator is going to come from the green column. So that was 14, right? The sums on the bottom are going to come from the second to last and the third to the last column. So x minus x mean squared, that was 10. And we're going to multiply that by the y minus y mean squared, which was 20. Now, the other thing you want to look for is in that formula, there is a square root over all of the denominator. So that last step is just putting that square root there. So my final calculation is going to be taking 14 divided by the square root of 200. Okay, so that's what the calculation is. You can make sure, try that calculation. I'll have it on the screen here in just a moment. So there's again, plugging in the sums, making that calculation, and we end up with 0.990. That is very, very close to 1. It's positive, so that means the direction is positive. So as you increase the volume of water, the time it takes to boil also increases, and it's a very strong relationship. That is almost next to 1. It's not quite perfect, but it's almost. Okay. So that interpretation, that's what we need to make sure we're making here, right? Using this table, this table is the one that we use to help guide us in our interpretation, but we just need to make sure we're familiar with, can I identify strong versus moderate versus weak? So for this one, it has a very strong correlation between the volume of water and time it takes to boil. As the volume of water increases, so does the time required. I'm going to stop this video here, and I'm going to start the next video with the next few examples.